Hello, in this video, we'll do a comparison between different models that I have in my local, which are MedLlama 2, Llama 3, Llama 3.1, and Llama 3.170B. And we'll do all the comparisons and see how the summaries of the patients look like and see how the matrix looks like for each of the model. Let's deep dive. So I have this patient information. So I have this patient search. Let's take the patient ID. We can either search with patient first name or patient last name or ID. So I'm going to pick ID. And this is Chloe Miller. So let's search here. So I got Chloe Miller here. And it started already. Okay, so yeah, the health summary is this way. The patient history, the summary is not that great. It is giving some invalid instructions. For me especially, I don't take this, even though MedLlama is trained with medical data. It's not giving proper results. So let's check with okay, so it's going to take a few seconds to update in WNV, and meanwhile we'll go to other model, which is Llama 3, and see how things goes. And we'll wait for WebSocket connection to be established from front end to back end, and looks like WS generate summary got established, connection is open. We'll go to other categories for this patient to see the history and see how Llama 3 is generating the summary. We'll go to conditions, and before going to the conditions, let me take you to the prompt templates that I have for conditions. So yeah, this is my template. Provide a summary of the patient medical conditions first, then identify patterns, make predictions, and suggest care plans with the provided data. So the data is the data from here. Conditions, yeah. So this is the data. So let's see how it generates. Let me go to conditions. Okay, it started immediately. Okay. Yeah, it has dates. Let's cross check the years. 2001, 2016, 2016. Let's check. Yeah, 2001, 2016, 2016. Perfect. So the date matches, and let's see the description: localized primary, acute, viral, last station of hand. Yep, all of them matches. And the model seeing the patterns, it is doing the predictions, and it is giving the care plans, what care this patient is supposed to take. And so far so good. And let me take a screenshot for this. Okay, let's go back to let's go to WNV and see if anything updated here. Okay, so Wally line is there. It has the more VRAM usage than W1. This Wave 1 is my Llama 2, and this is, it has different naming conventions. So the world leading line 2 is Llama 3. Um, it has nearly equal tokens per second. So it has, the Llama 2 has 80.138 tokens per second, and this has 78.7, and it has 89% of GPU utilization. And let's go to others. Okay, this is how it has more GPU temperature than Llama 3, and yeah, the prompt evaluation count is 165, and it has 742. And let's go to total duration in seconds. Yeah, it took, Llama 3 took like 9 seconds to analyze and provide like total stream of the response, and this took 3.07 seconds because even we saw the response is very short. Maybe that's the reason. And let's go to others. So yeah, it's pretty much generic. Okay, so okay, we're done with Llama 3, and we'll compare with Llama 3.1, which is the latest 4-bit quantized 8 billion parameters instruct model. So let's use this, and every time we run, we have playful sound, and see if it appears here. Okay, we have playful sound, and we have the connection established. So we'll go to, okay, we'll again go to the conditions and see how it is giving the answers. So, okay, the data went to the backend. Yeah, okay. Yeah, it is also giving pretty much good responses. It is seeing the patterns, short-term patterns, and it is trying to get the multiple conditions. It is trying to do some predictions, and it is suggesting to do some strengthening exercises with the patient current medical conditions. It is doing care plan sessions, which is pretty good. At Llama 3.1, it's a good output. So let's go to the charts. Okay, we have VRAM usage, and we have fan speed pretty much the same for Llama 3 and Llama 3.1, and we have the load duration pretty much same, both of them same. The GPU utilization reduced, which is 86%, and it is generating 76 tokens per second. Interesting. Okay, the power capacity seems very consistent, and the GPU temperature got reduced a bit for Llama 3.1 instruct model, and the prompt evaluation count is 169, and the evaluation count is 440 here, increased, and the total duration is 9.466. It increased a little bit. Evaluation duration in seconds, so it took a bit of time. And let's go to other. Yeah, prompt evaluation duration per seconds. Okay, so yeah, that's pretty much it for 3.1. Let's go to 3.1 70-bit instruct quantized 4. Okay, let's go to this model. It might be a little bit delay in loading because it's a 40 gig model. The AMD Radeon Pro 77900 is 48 GB, so it still works, but it's going to take some time because it's a 40 gig GPU. So let's enjoy the thunder. Okay, let's take this screenshot for comparison. Okay, let's see if the connection is established. Looks like the connection is established, and we'll start with the conditions again. Okay, the data went to the backend. The data is retrieving very quickly. So previously I was using these tables where I saved all the patient information. When I tried to group from patients to each of the category of the patient, so it used to take a lot of time. So like 20-25 seconds in order to fetch and respond to the message. So it's a lot of time. So yeah, the model seems started giving the output, and it's kind of slow. Maybe I think it's because of its size. Let's say there is the patient history still ongoing. Job in this age. Okay. Okay, we'll see how things are working, and before that we'll go to Sweet. Nice. So the Jolly Thunder 4 is for Llama 3.17 KB instruct model. So the VRAM usage is 92%, which is expected, and the fan speed is like it's a lot. The GPU utilization is 76. Okay. So the load duration, yeah, like we see, so it took a lot of time loading the model into the GPU. So it's a lot of time. So when compared to these two, it's a lot. So tokens per second. Yeah. So it's very easy to compare. So for smaller models, we're getting nearly 80 tokens per second. It's very large model, and it's taking like 13.5 tokens per second, which is pretty much slow. And we'll still anyway we'll compare 3.1 instruct model and this output and see which is doing better in terms of summarizing, and we can finalize that model. Okay, power capacity, full capacity, GPU temperature is 73. Okay, and prompt evaluation count is 168, and evaluation count is 505. Total duration in seconds, yeah, it took a lot of time to totally respond uh, to the given summary of a provided category. So when compared to these two, we can see the differences. And about the evaluation duration seconds, in like, yeah, it has like 37. Yeah, it has like 37 when compared to the rest of them. They are like 5, 2. So let's go to other metrics. So this is also evaluation duration seconds. Yeah. Okay. Let's see if we can find some other metrics. Then that should be.